Well, the course that we teach every year here in the Industrial Design Department is called Design for Extreme Environments. It's looking at how people design and solve problems in really unusual environments, in unusual circumstances. When the students work with engineers and architects and designers from NASA, they're getting a very real-world perspective. And whether you're designing for the moon or designing a new building or a new product, there are all sorts of constraints that come into play.
Behind us are two concepts for the suit lock for the future lunar lander. This is a project that we did with the Johnson Space Center in Houston. So basically we were asked to come up with two concepts, one more radical and one more simplistic. They were both meant to solve the same problem of ergonomically fitting into spacesuits in which you can climb in and leave the lunar lander safely and then come back without transporting the lunar dust into the main spaceship.
The astronaut climbs up the back of the bulkhead using the handlebars and slides foot first into the suit. The suit's in a seated position so they can slide their feet in and rest their rear on the built-in seat. Once they're suited, something like this, which is representing the portable life support system, is going to swing shut and close the door and seal the opening between the habitat and the airlock.
Typically we work very much on our own, and like I said, it's very theoretical, which is the beauty of being at RISD, but this was a fantastic supplement because for grad school we're only here for 2 years. So this summer project with 5 of us, 2 undergrads and 3 grad students, was really fantastic in that we were working as a team and we were working with real life factors.
I guess my favorite part was building the test rig to simulate all the different angles that we could possibly design this contraption to be at.
To that point, when you work with a company like NASA, you get a lot of information from them, from the engineers, and there's not a whole lot of room for design, but that exploration element was probably the most fun.
It actually, I felt like, opened up a lot of creativity because of the problem solving it required. Sort of having that box handed to you, like, okay, here are all the limits that you need to work with, and pushing all the puzzle pieces around and coming up with a solution was really, in the end, really exciting.
Aside from these fins, the internal dimension that you created here mimics the internal. Right now I'm standing in the Industrial Design Gallery where we have a display of work that we've been doing in partnership with NASA. When I came in the door, I didn't know what I was going to see. And I think what amazed me was the scale of what we're doing. It's full-scale work. It's work that is not just theoretical, but it's actually put into physical form, in a physical form that gives you a real sense of what it would be like to be in that environment. I think the benefit for students is that students get an opportunity to look at how the world of corporations and industries think and work. They can go back to their own studies here at RISD with the corporate perspective in mind, which can enhance and guide them in their own thinking about their work and their careers.